Hello and welcome to the show. Today, we're diving into a fascinating piece of technology that's essentially teaching machines how to smell. AI-powered electronic noses, or e-noses. Imagine a device that can detect and interpret smells just like our own noses, but potentially even better in some ways. These aren't just simple sensors. They're sophisticated systems combining advanced sensor technology with powerful artificial intelligence. So, how does an e-nose actually work? At its core, it uses an array of tiny gas sensors. Think of sensors made from materials like metal oxides or conducting polymers. When air containing smells, specifically volatile organic compounds or VOCs, flows over these sensors, each sensor reacts slightly differently depending on the chemicals present. This creates a unique pattern, almost like a digital fingerprint for that specific smell. It's this odor fingerprint that holds the key information. But just getting a fingerprint isn't enough. This raw sensor data is complex. That's where the AI part comes in. And it's absolutely crucial. Artificial intelligence, especially machine learning and deep learning algorithms like neural networks, are trained on vast databases of these odor fingerprints. They learn to recognize incredibly subtle differences and complex patterns within the data. This allows the e-nose to not just detect a smell, but to identify what it is, classify it, and even measure its concentration with remarkable accuracy. In many cases, AI helps these systems outperform human noses in terms of consistency and sensitivity, and they can automatically analyze data and even learn and improve over time. The potential applications for this technology are incredibly diverse. One of the most exciting areas is medical diagnostics. Our breath, sweat, and urine contain VOCs that can act as biomarkers for various diseases. E-noses are being developed to sniff out these biomarkers, offering a non-invasive, fast, and potentially cheaper way to detect conditions like cancers, diabetes, respiratory diseases, and infections, sometimes at very early stages. Imagine getting screened for a serious illness simply by breathing into a device. There's even work on integrating these into telehealth for remote patient monitoring. Another huge area is food quality and safety. E-noses are already being used to check the freshness of meat, fish, and dairy products, detect spoilage or harmful contaminants, verify if that expensive olive oil or coffee blend is authentic, and monitor processes like fermentation. This technology can help ensure the food we eat is safe, maintain quality, and even help reduce food waste by providing more accurate shelf life assessments. Some concepts even involve smartphone apps reading color-changing labels analyzed by AI to tell you if your food is still good. Beyond that, e-noses are valuable for environmental monitoring, detecting pollutants or toxic gases in the air and water in real time. In industrial settings, they can monitor for hazardous gas leaks, check emissions, and even help predict when machinery might fail by detecting chemical changes in lubricants. They're also giving robots a sense of smell, making them safer and more capable in hazardous environments. The list goes on: security applications for detecting explosives, agriculture for checking crop ripeness, quality control in cosmetics, and even potential uses in smart homes. The technology is constantly advancing. We're seeing smaller, more portable sensors thanks to microelectromechanical systems, or MEMS. Sensor materials are improving, making them more sensitive, and the AI algorithms, especially deep learning, are getting smarter, better able to handle complex mixtures of smells. Integration with smartphones and the Internet of Things is making e-noses more connected and accessible. Of course, challenges remain. Things like standardizing the technology, dealing with sensor drift over time, cost, and getting regulatory approval, especially for medical uses. But the direction is clear. AI-powered electronic noses are set to become increasingly common, offering us powerful new ways to understand the world through the sense of smell. It's a glimpse into a future where technology engages with our environment in ways we're only beginning to explore. That's all for today. Thanks for tuning in.